Sex-linked chromosomes. X-linked genes. Humans have 46 chromosomes, or in other words, 23 pairs. 2 of those 46 are sex chromosomes, referred to as X and Y. So when we did our karyotypes, excuse me, those karyotypes had on the 23rd pair, they had either 2 X chromosomes or an X and a Y, like shown in the picture. So XX would indicate a female and XY would be a male. Sperm determine the sex of the child. Egg always provides an X chromosome, as mothers only have X chromosomes. During meiosis in males, the X and Y chromosomes separate. Move that around a little bit. Okay, come on now. Alright, so sperm carrying X chromosome fertilizes the egg, then you get a baby girl. If the sperm carrying Y chromosome fertilizes the egg, you get a baby boy. X-linked disorders. X-linked genetic disorders are more common in males. This is because X-linked disorders are recessive and males only get one X chromosome. Females can be unaffected carriers of a trait. That is, they themselves don't have it, but then they pass it on to the next generation. Affected females could be X lowercase, X lowercase. That would indicate a recessive trait. An unaffected female would be X capital, or they could also be unaffected and be a carrier female, which would be X capital, X lowercase. In other words, they themselves wouldn't have it, but they could pass it on to their offspring. An affected male would be X lowercase y, and an unaffected male would be X capital Y. The Y chromosome is always left blank because it lacks the genes. Since we're just tracking X-linked disorders here, we wouldn't have anything on the Y. There are Y-linked disorders, but that's not what we're covering in this unit. If males have a recessive allele, they have the disease because they only have one shot at an X. And so if that X has the disorder, like in this case, then the male is affected. See how far I can turn myself over here. Alright. Some genes reside on the X chromosome and can cause genetic disorders. These disorders are almost always recessive. Because they are located on the X chromosome, there are some unusual patterns. Examples of X-linked disorders like color blindness, hemophilia, muscular dystrophy, those are things that would be carried on the X chromosome, or the bigger one, on the 23rd pair. Can you see these numbers? If you cannot, you might have some degree of color blindness. Hemophilia is a recessive X-linked disorder in which there is absence of blood clotting factors. This can lead to excessive bleeding when blood vessels are broken. An example is Queen Victoria of England. She was a carrier of hemophilia and passed down the disorder to her son Leopold, as well as some other daughters who were also carriers. So here's Queen Victoria here. She probably didn't know at the time, but she was a carrier for hemophilia. And she marries Albert. And they have 4 children. First one a normal male. The second one's a carrier female. When she gives birth to Leopold, she realizes that she's a carrier because then he ends up with hemophilia. Now, they didn't know all this carrier stuff and, fancy words for everything, but they did know that it was getting passed on, and they did know that it wasn't affecting the females. So whether or not they knew the mother was the one that was passing it on, I don't know. Probably not, but they did realize that only the males were getting the disorder. So Alice and Beatrice are carriers. They figure that out because they have children that are affected, like another Leopold and Frederick. They are affected. Let's see here. Alice is affected because she has Rupert here, and so on and so forth with the rest of them. Solve this. Queen Victoria had 8 children, 5 girls and 3 boys. One of her children, Leopold, had hemophilia. The other 2 sons were normal. The other children were normal. So, Queen Victoria is a female. That means we represent her with XX. Albert was a male, so we represent him with XY. That is Leopold. We know that he has the disorder, and so nowadays we know that means he is X lowercase y, H for hemophilia, so X lowercase hy. So we know that she must have been a carrier because otherwise her son wouldn't have gotten it. So males always inherit the X chromosome from their mother, because if they inherit an X from their dad, then they're not a boy, they're a girl. So they always have to inherit the X from their mother. So that superscript H there got passed on to Leopold. We know that she did not have the disorder, so her other allele must be X capital H. So she was a carrier of the trait. If they're heterozygous like this, that means they don't have it, but they could pass it on to their offspring, which makes them a carrier. And Albert must have been X capital H because he didn't have it, and his other chromosome has to be a Y or he wouldn't be a he. So he was normal, didn't have the disorder. So one possibility of children they could have is a female XX who is homozygous dominant, that is not affected by the disorder at all. She's not even a carrier. They could have a boy that is unaffected. They could have had girls that were carriers, which they did have several of those. We see on your pedigree from the previous page. Now I want you to try this one on your own. In fruit flies, the gene for eye color is located on the X chromosome. Red eyes are dominant, white eyes are recessive. Cross a red-eyed male with a heterozygous female. So red-eyed male means he has to be X capital RY. And then we have a heterozygous female. Heterozygous female must be X capital R, X lowercase r. So you'll put those parents along the top and the side and cross those. Give me your genotypic and phenotypic results.